Hello everyone. Welcome to the next lecture on the CSR Net Mathematics 2025. Today I will explain you with the help of the shortcut tricks how you can solve the real analysis question which was asked in the Assam 2025 paper. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the CSR Net. In this playlist you can see all these lectures available with the help of the shortcut tricks and free of cost. You can follow, watch and learn the complete shortcut tricks how you can get the answer in a reasonable time. Now let's start with the first question. As I mentioned you, in every time you have maximum 1 minute time periods to solve the problem, and always read the statement very carefully. In these questions, A and B are the two non-empty finite subset. That means non-empty subset. So that means you can choose A is either a singleton set, A is my closed interval, say 0, 1, A is my semi-open and semi-closed intervals, and so on. Fine. There is no restriction on that. S, T and U are the functions which are defined like this way, and your target is to mapping for the continuity. How you can solve this question in a 1 minute time periods? If you remember, if you already watched my last minute revision lecture on the CSR net on the real analysis, fine, then you can solve this question in a 15 second. Yes, you heard the same. 15 second time period you are needed if you already watched my real analysis last minute's lecture. What is the shortcut tips? As I mentioned you, if F is a mapping from A to B such that cardinality of A is cardinality of the B, that means there exists a bijective map. Fine. That's a simple shortcut tricks as I mentioned you. Now we can apply the same shortcut tricks for you in this example. A is a finite, then there exists a bijective map. Say H is a map from S to U. So that means your target is to check whether the cardinality of S and cardinality of U are same or not. A is a finite set. So for the simplest cases, I can choose this value. Can you find the cardinality of the S? Cardinality of S means cardinality of the map. And if you remember, if F is a mapping from A to B, how you can find the cardinality of the F? That is number of the maps. Number of the maps means how many functions go from A to B, which is equal to cardinality of B raised to power cardinality of A. So can you find the cardinality of the S? Cardinality of R is my C. Cardinality of A is my 1. Can you find the cardinality of the U? Cardinality of U is my C. Cardinality of A is my 1. Cardinality of A is my 1. It is a C square, which is again C. And both are same. Yes, there exists a bijective map. But because this is a one example, you can say we can't correct about this problem. Because if you take as A is my this case, A is my this, then we may discard them. Look at these second options. If A is finite, I can choose A is my this case, B is my 0, 1. So I can choose B is my 0, 1. There exists no bijective map from S to T. Cardinality of the S is still C. Fine, because I can choose A is my here. What is the cardinality of the T? T is my cardinality of the C raised to power cardinality of B, which is again a C. Fine. So both are same. Yes, there exists a bijective map from S to T, but he said no bijective map. There is no bijective map from S to U, but we can see that there exists a bijective map from S to U. Look at the fourth case. A is not equal to B. I can choose A is my 1, B is my 2. Both are my singleton set. There is no bijective map from the T to the U. So can you find the cardinality of the T? R, that is a C raised to power 1, that is my C. Cardinality of U, C square, that is again C. Both are same, so yes, there exists a bijective map, but he said no. So the only left option is my A is the right answer of the problem. You can see that based on the single concept about the cardinality, or you can watch for more details. you can watch about my this lecture PY question on the countability. You can get the answer in a very, very reasonable time. Okay, look at this second one. F is a bijective function. F is my bijective functions. The only condition is my bijective such that f of x is my greater than equal to 0. Fine, because the range is my codomain is my 0 to positive. Can you think about any of the function which is always the positive? It is either e raised to power x, or it is mod of x, or it will be x square. Is it okay? This is the only function which is always the positive, or cos x? No. Can you say the cos x is always positive? No, when it lies in the second quadrant, it's a negative. So for the sake of convenience, I will take about here. F is a monotonic, F is a continuous, and here. Look at that. They are only talking about the bijective map. Whether they are monotonic, whether they are continuous, whether they are discontinuous. Have they talking about this case? No. It may or may not be there. So it's a very, very simple question. Once you have analyzed this case, whether they are monotonic, so I will think about these examples. Can you construct a function, or one more thing is constant function? Fine, constant function, let's say 3 or 1 or 3 or 7, positive constant numbers. So it is always a positive. So can you think about a functions which is a continuous, not continuous, monotonic, and so on? If I choose whenever x is my greater than 0, this value say my x plus 1, it is always positive. Whenever x is my less than 0, I can choose any number, say mod f, or I can choose a minus of x. Fine. It is always the positive number. Now, whether it's a monotonic, check whether it's a monotonic or not. You can see f dash, it is 1 minus 1. Whenever x is greater than 0, x is less than 0. That means this is not monotonic, because the rate of change is not a constant. So it is not a monotonic. Not a constant means it is not has the same sign. Sometimes it's a positive, sometimes it's a negative. That means it is not a monotonic. A option is cancelled. Whether it's a continuous or not, you can clearly say at the point 0, the left hand limit will be 1, while the left hand limit will be 0. Right hand limit is my 1, which is not same. That means the function is not continuous. So the B option is cancelled, D option is cancelled, C option is the left behind is the right answer of the problem. Moreover, you can also see that this function is my bijective. How? You can draw the graph. Whenever x is greater than equal to 0, the value is my 1. Whenever x is my less than 0, the graph will be here. So clearly say this is my bijective. On the x is less than 0, it is 1, 1 and on 2. Whenever x is my greater than 0, it is 1, 1 and on 2. And the complete function is also 1, 1 and on 2. So the right answer of this problem is my C is the right answer. You can see that I can simply choose the functions based on this. Okay, look at this another one. F is a mapping from the non-constant continuous functions. Can you choose about any of the continuous functions? Again, you can choose either as a e raised to power x, either as a constant, either as a polynomials, x plus 1, or you can choose as a sin x, or any of the functions are there. These are my continuous function, but the given statement said is a non-constant. That means this case will be cancelled. Fine. Now based on these simple 3 pairs, I can choose the given options. Okay, firstly I can choose the fx is x square. Can any option be discarded? Always remember your target is to discard the options. Look at the 4th option will be cancelled out. Can you find any of the x which will be 0? No. So 4th option will be cancelled out. Look at the 3rd options. F of x is x. If you choose f of x is my x plus 1, can you find the value of the fx is x? No, because x can never be equal to x plus 1. So C option is also cancelled out. 3rd option is a Cauchy sequence, and the first option is a bounded. So Cauchy sequence we need to construct as a subsequence and so on, we will check about the bounded subset. You can choose any of the bounded subset. Let's say A comma B, which is a bounded subset of the R. Then F inverse. Always remember, student, if F is my continuous functions, it doesn't implies F inverse is also continuous. It doesn't implies that. That's you all knows. And when it will be the continuous, if it is given that F is continuous and monotonic, then you can say about whether F inverse is a continuous or not. But whenever F is only the continuous, F inverse need not be continuous. Fine. So because F inverse is need not be continuous, then I can think about any of the discontinuous functions of the F inverse. So first of all, what is the F inverse? F inverse of the A, that means collection of all those x from the R such that f of x belongs to the my AB. Fine. Now your target is to check whether this set is bounded or unbounded. Fine. Now I can choose f. If you choose the sign of x, then the sign inverse is also the bounded functions, -1 to -1. Can you think about any of the function whose inverse is unbounded? The only contradiction will be the tan inverse. So I can choose collection of all those x, so that tan inverse x, and I can choose this value is my interval is my -π/2 to +π/2. Fine, which is the bounded. So can you find the value of the x? Collection of what is the tan of the π/2? -π/2 is -∞. That means collection of the x is my r. And what is the r? R is my unbounded. And once r is my unbounded, you can see the first option is cancelled out. The only left behind is my B option is the correct option. So you can see that based on the single examples. For more details, you can watch about my this lecture on the continuity. PY question of the continuity. If you watch my this lecture, then you can able to understand how you can solve the question in a very, very simple manner. Okay, look at this another question. Okay, if you want, I can upload this is the real analysis video. If you want to upload, I can upload the real analysis, complex analysis, linear algebra, differential equations solution of this examination paper. You have to like, subscribe and comment on the video. If I get the good likes and comment and the subscription on this video, then I will upload the next video very soon. Now, how you can solve these questions in a 1 minute time periods? Again, a very simple, and you can see all these three questions that I have explained you, the same approach that I have explained in my previous lectures, as well as the last minute video, revision video on the real analysis. Fine. How you can solve this question? That is a sequence. What is the meaning of limit is my finite? What does it mean? That means the subsequence is my convergent. The subsequence is my convergent. Once the subsequence is convergent, then what is the meaning of that? Limit infimum of the subsequence, which is same as limit supremum of the subsequence. This is fine. Now, so that means the last option is cancelled. Limit of the infimum of the subsequence is greater than 225. That is wrong because it will be convergent. Now your target is to find the relation between the subsequence and sequence. The same shortcut tricks as I have given you in my last minute revisions of the real analysis. What is the shortcut tricks is? Limit infimum of the sequence is always be less than or equal to limit infimum of the subsequence. It is always be less than equal to limit supremum of the subsequence, and it is always be less than of the limit supremum of the sequence. Now you can substitute the value. It will be limit infimum of the sequence. This number is my 2025. This number is also 2025. which is less than of the limit supremum of. Now based on this result, you can simply discard the options. Look at the first option, limit infimum of the sequence greater than equal to 2025. That's wrong. It is a less than equal to 2025. Limit of the supremum of the xn is less than equal to 2025. That's wrong because it is greater than equal to 2025. Limit infimum of the xn is less than equal to 2025. That is the C is the right answer of this problem. You can see that how many seconds you are needed to solve the problem. Maximum of the 15 seconds if you already watch my last minute revision lecture. Okay, look at this another one. Consider the sequence Fn. Which of the following statement is true about the uniform convergent, uniform convergent, uniform convergent, uniform convergent? I think you already understand how you can solve the problem. They are talking about the series. Fine. So firstly, you have to check about the pointwise convergent. So that means your target is to check whether limit n approaches infinity of Fn is finite or not. The interval is -1 to +1. If you choose x is -1, if you choose x is +1, or if you choose x is my -1 to +1. If you choose x is my -1, so this limit will be 1 plus n over n square. Now if you take the limit as n approaches infinity, this number will be 0. Similarly, if you choose x is 1, it is again 0. If you choose from -1 to 1, so that number will again be n upon n square, it is again 0. So yes, this number is my pointwise convergent. Fine. Now, second, once you can see the pointwise convergent, then your target is to check whether Fn minus f will goes to the 0 as n approaches infinity or not. If this goes to the 0, then you can say the series is my uniform convergent. Is it okay? यही concept था ना आपके पास by using the Cauchy criteria. Now you can solve it. What is the Fn? Absolute value -1 x square plus n over n square minus f. F is my 0. So that is basically my this case. Fine. So this number will be x square plus n over n square. Now your target is to find the limits over the -1 to 1. So x belongs to the -1 to 1 is the modulus value. Clearly say the largest value is my 1. So it is less than or equal to 1 plus n over n square. And you can see this number will goes to the 0 as n approaches infinity because the degree of the denominator is more. Therefore, f series of the Fn is my uniform convergent. So that means the D option is cancelled. C option is cancelled. Similarly, if you look about the Gn, again, the only difference in the Gn is my n square. Fine. But again, the Gn is my pointwise. This is my n square. This is my n square. Denominator is n cube. So what will happen is n square and n cube. So again, you can see this will go to the 0. Yes, series Gn is also uniform convergent. So A is the right answer of this problem. Because they are talking about the on the interval -1 to 1. The x values remain the same on the both cases. So that's a simple way. And for more details, you can watch about my uniform convergent, fine, or uniform continuous lecture, or you can say the series of the functions. You can watch about my lecture on the series of the function, uniform convergence, sequence and series of the functions. Okay, look at this next one. Consider the sequence and they are talking about the convergent. What is the tip? As I mentioned you always, whenever you have seen the sequence, your target is to compute the limit of the sequence. If this limit is my finite and unique, then you can say this sequence is my convergent. So that means your target is to find the limit of the an. So that means limit n approaches infinity -2 root n plus summation k varies from 1 to n, 1 by root k. Fine. That is fine. How you can find the limits of this case? Again, a very simple. Firstly, I will tell you, whenever you will say the k is equal to 1 to n f of xk, fine. If this function f is always a positive and decreasing, whenever this f will satisfy these two properties, then you can approximate these functions to be integration of the fx from 1 to n. Whenever the function will satisfy by these two properties, then you can find these summations. Now you can see 1 over root x, it is always a positive and it is my decreasing. So therefore, I can solve this is 1 over root x from limits are my 1 to n. It is 1 to n. So can you solve these integrations? It will be 2i's root of the x from 1 to n. You all know it will be minus of half plus 1 over minus half plus 1. So the answer is 2 root n minus 1. I can substitute this value at this point. So it is a limit minus 2 root n plus 2 root n minus of 2. Minus 2. Now you can see that what will happen if n approaches infinity, which is 2, which is finite and unique. So therefore, the limit an is a finite and unique. The sequence an is convergent. So B option is cancelled, D option is cancelled. Now similarly for the Bn, what will happen Bn? Again you can see this part is my convergent, is a increasing and decreasing, is a decreasing and positive. So I can find the value of the Bn again by using the same rule. The only difference is the first term will be my n plus 1. It is minus of 2 n plus 1. In that case, this quantity is not cancelled out. So I can solve this part. I can take 2 is my common, limit n approaches infinity. This is my root n minus and minus of 2. For this case, I can rationalize them. If you rationalize them, it will be my root n will be cancelled out. That will be my minus 1 root n plus, fine. Now if you taken 2 as a common, it will be my 1. Now if you take limit n approaches infinity, this will goes to the 0. The answer is my minus of 2, which is finite and unique. Once this is finite and unique, then you can say this is also convergent. So the first option is cancelled. C option is the right answer of this problem. So you can see that it's a very simple way you can get the answers. I hope you can like and comment on this video if you are really interested to watch the next videos on the real analysis, complex differentials very soon. Okay, consider the real matrix. Okay, this is a bilinear form. So basically this question is from the linear algebra, but let me explain you in this is a very simple manner. B of VV. So what is the B of VV is 0 if and only if. Very simple. Can you write this A matrix in terms of this is my V1, this is V2, this is V3, this is W1, W2, W3. If you look about this value, it will be V1, W3 plus V2, W2 and V3, W1. Is it fine? Now look at the first options. BB, VV, both are same. That means W is equal to same. So this function I call this is my fx, or you can say VV. It will be twice V1, V3, fine, plus V2 square. 0 if and only if this is 0, can you say the V is 0? No. Why? Because you can see that I can choose V2 is my 0. Oh, sorry. I can choose, fine. I can choose V2 is my 0, V1 is my 0 and V3 is my 1. And you can substitute here, it will be 0, but this number is my non-zero. Fine. Or you can also choose another number. Say V1 is my minus half. Fine. V3 is my 1. So this number is my minus 1. So again you can see this is my non-zero and V of V is my 0. So first option is cancelled. Fine. Second one. For every value of lambda, there exists a V. Again, you can see what is the value of the V comma V. It will be V2 square plus twice V1, V3. For every value of lambda, there exists V of V. Okay, we will see the third case firstly. There exists a V which is a non-zero. You can choose any of the non-zero number, say 1, 0, 0. Such that V of V is 0. So W I can choose any number. Fine. Such that it will be 0 for all. So you can substitute the value at this point. What will happen? V of VW. So V2 will be 0. V3 will be 0. It will be my V1 is 1. Fine. It is a 0 for all W. That's strong. If I choose V is my 1, 0, 1. Fine. So W3 is my non-zero. So this number is my non-zero. For every V is my. So third option is also cancelled. VW is 0. Then either V is 0 or W is equal to 0. Again you can see. If I choose V is equal to either this 0 or W is equal to 0. How you can say that? V is 0. So I can choose. Okay, fine. I can choose V is my 1, 0, 0. W I can choose as again 1, 0, 0. Fine. What will happen? This number will be my 0. So this property is satisfied. Fine. Once this property is satisfied, then either V is 0 but V is my non-zero or W is my non-zero. So D option is also cancelled. And you can see the last option which is left behind. B is the right answer. But how the right answer is there? You can see we have obtained the value of the V comma V is my this number. For every value of the lambda, let's say lambda is my 3. You can easily choose the value of the V1, V2 and V3 so that this number will be 3. How? You can choose V2 is my 1, 1 and 1. I can simply choose V is my 1, 1, 1. Then it will be 3. If you choose this number is my 31, again I can choose the 31. I can choose the V1 is my 31 over 2. V2 will be my 0. V3 will be my 1. Fine. For every value of lambda, you can choose, because you can choose V2 is 0 and V1 is my lambda over 2 and V3 will be my 0. Fine. So there exists a V which is a lambda by 2, 0 and 0, so that this value is my true. So the right answer of the problem is B is the right answer. You can see that all these questions that I have explained you, all are with the help of the shortcut tricks. I hope you can enjoy this session too, and let me know in the comment box whether you are interested in this lecture or not. I will upload the next lecture soon if you get the good comments and the like on this video. Till then, you can share this video with your friends. Best of luck, students, and don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.